Hello, precalculus class. Today you're going to learn about something called the determinant of a matrix. And the reason we're going to find determinants, it is another way to solve a system of equations. So take a look at this warm-up, read through it, and can you figure out how this number, called the determinant, is calculated? Pause the video. Did you figure it out? So each of these numbers here is called a determinant. And this is a 2 by 2 determinant of a square matrix. So you can do a determinant on a 2 by 2, a 3 by 3, a 4 by 4. And when you think about that, those are going to be the coefficients of a system of equations where you have the same number of equations as you have unknown variables. So let's show you where these numbers come from. The key is you multiply the first diagonal and then you subtract the second diagonal. So 3 times 2 is 6 minus -4. And bingo, you get 10. Let's look at the next one. So the down diagonal product is -3 minus the up diagonal, which in this case is 0. And there's -3. And the last one, the down diagonals product is -8 minus the up diagonals product, which in this case is -35. So it's -8 plus 35, and you get +27. So it's just a quick calculated number that we are going to use to solve a system of equations. So you've already learned how to solve a system of equations using matrices, doing something called a row echelon form. Today we're learning about determinants, and next lesson we'll learn about Cramer's rule, which we can use the two of those to solve a system of equations using matrices. And then the last lesson we'll have in solving a system using matrices is something called an inverse matrix and matrix multiplication, which you already learned. All right, these are just the notes of what we talked about already, where we're looking at the two diagonals, the down diagonal, subtracting the up diagonal, and getting our determinant value. So go ahead and find the determinant for this example right here. Pause the video, and then we'll check your work. All right, let's look at your answer. So our down diagonal, the product is 2 minus the up diagonal, which is 12, and we end up with -10. One other important note I must make right now is take a look at the symbol. So here, they're just using straight lines without the little brackets. That symbol means determinant. So even if I just said evaluate this right here, with those two symbols, it means find the determinant. Note, if I had the matrix, I would have had that with the brackets, and then I can't say evaluate it because I would have to say find the determinant of this matrix. So just some notation to be aware of. If you just have the two lines, it means the determinant of that matrix. Here's 2 more examples for you to try. Go ahead, pause the video, and then I'll give you the answers. And here are your answers. The first one is -5, and the second one is 0. Pay close attention. If a determinant equals 0, and you're solving a systems of equations, you're going to find you either have an inconsistent system with no solutions or a dependent system with infinite solutions. And we'll talk more about that later. All right. Now we have to find a 3 by 3 determinant. And you can also find a 4 by 4 determinant, 5 by 5, and it gets progressively harder. We thought 2 by 2 was easy. Well, there's 2 methods for a 3 by 3. One's called the diagonal method, and the other's called expansion by minors. I actually like the diagonal method better, and I'm going to show you both. But the expansion by minors method is expandable, which means that's the one that you would do on the 4 by 4 and the 5 by 5 going forward. So we will go over both of these. Okay, here's the diagonal method. So first thing you want to do is look and recopy the first two columns of data right to the right of the matrix. Then notice the little calculation. Now that's a lot to memorize with letters. So notice that we have some what we're going to call the down diagonals in pink, and we have some up diagonals in blue. Well, the down diagonals are these three products, and the up diagonals are these three products. So this is your down, and this is your up. And the key is you add the products of the down diagonals and you subtract the products of the up diagonals. So that's not that bad to remember. All right, let's do the example. The first thing I'll do is rewrite the first two columns. All right, and now I'm going to look at my down diagonals. So I'm just going to put lines like that so that I don't override the numbers. So the first product is 35. The next product is 4, so we're adding these. And the last product is 18. I'll change colors, and now we're going to do the up diagonals. So we're going to subtract 10, and then we're going to subtract 6. And lastly, we'll subtract 42. 7 times 3 times 2. And the final step is to add this all together, and we end up with a determinant of -1. Okay, so here's the second method. This is called expansion by minors. The key here is you pick any row or column you are interested in, and you're going to expand along that. So for instance, in this example up at the top here, I chose the top row. So see how we have A11, A12, and A13. So those are listed here. And because I'm expanding along the first or third row, my pattern is going to be plus, minus, plus. So I have positive, minus, positive. And if I choose A11 as my first multiplier, then I'm going to multiply it by the determinant, cross out the row below it, or the column below it and the row across. I'm going to multiply it by the determinant of what's left, what we call the minors. So I'm going to have to find this determinant of this 2 by 2 right here, and I'll be multiplying those together. Then I will move on to the next value in the row. And when I eliminate that column and that row, these are the four numbers, A21, A31, A23, A33, that will be in the determinant that we're going to find while we multiply by the A12. And lastly, if we go to our last value in the row, which is A13, we cross off that row and that column, and we're going to be multiplying A13 times the determinant of the minor. You do want to pick wisely with which row or column you're expanding by. In that, if you can find one with a bunch of zeros or ones, you have to get to, more luckily, eliminate a bunch. The other thing is this note here, it's easier just to remember if you end up with an even number, so 1 plus 1 is 2, then it's going to be plus, minus, plus. If you choose one like this one here, 2 plus 3 is odd, then it's minus, plus, minus. So I just write down evens is plus, minus, plus, and odd sum is minus, plus, minus. And that, to me, is an easier way to remember it. Okay, let's look at the example. So we are going to use this right here. And because we have a 0 in the top row, I think I'll do it just like the original example showed, where we expanded by the top row. So the determinant of this 3 by 3 matrix will be -1 times the determinant of, when we kind of ignore this and ignore this. The determinant of 2, 1, 1, negative 1. And then our next one is the minus. So we'll do minus 2 times, when we kind of eliminate that column and row, we have 3, negative 2, 1, negative 1 for our minors. And this is why I chose the top row. My next one is a plus 0. It really doesn't matter, but for purposes, we'll look at this, which is the minors, 3, 2, negative 2, 1. So now we just have to evaluate those determinants. So it's negative 1 times negative 2 minus 1, minus 2 times negative 3 minus negative 2, plus 0. I'm not going to waste my time there. Now I'll simplify. Just the key is be careful with all these signs. We end up with a 3 plus a 2, and our answer is 5. Okay, I think we should practice that. So you want to find the determinant of this. You can do it either method. Go ahead and pause the video, and then when you unpause, I'm going to do it both ways. So you can look at both methods or the one you like best. I will not tell you which method you have to use. Okay, so the determinant for this 3 by 3 is 126. Take a look at the diagonal method. So the first thing I did was wrote my 2 columns again, and then my down diagonals, the products are being added together. So we have 6 plus 96 plus 2. And then my up diagonals are being subtracted. So minus negative 16, minus 6, and minus negative 12. I always write out all my signs and then I simplify. And when you add all that up, you get 126. All right, the expansion by minors, I chose the best I could. I didn't have any zeros, but I went ahead and chose the first column. So both of those, I had 2 1s, so I thought that would be easier. So the first thing I did was wrote out my expansion. So I take the first value, and since it's the 1 1 position, which adds up to 2, it's even. So it's positive minus positive. So when you expand on the 1, you're left with 2, 6, 1, 3. Then you expand minus negative 1, and you're left with 4, negative 2, 1, 3. And then you expand by the bottom row here, 4, or the bottom value in this column, plus 4, and you're left with 4, negative 2, 2, 6. So then it's 1 times 6 minus 6, plus 1 times 12 minus negative 2, plus 4 times 24 minus negative 4. So you have 0 plus 1 times 14 plus 4 times 28, which is 126. So either way, you should get to the right answer. And remember, I could have expanded on any of these rows and columns, and I'll still get 126. Hopefully you got that right and are finding success. Okay, so here's some properties of determinants, and let's just read through these. If we were in class, I would probably have you split into groups and have you actually test out each of these. So feel free to test these out, and I could see on a test or a quiz you being asked to test one of these out. So the first one, the value of a determinant changes sign if any 2 rows or any 2 columns are interchanged. How I would test that is come up with a determinant, just either a 2 by 2 or a 3 by 3, calculate it out, then switch 2 rows and calculate it again and see that, let's say the answer was 3, now it's negative 3. Or if the answer was negative 17, now it's positive 17. The next one, if all entries in any row or any column equals 0, the value of the determinant is 0. That one's really quick to test. Go ahead, create maybe a determinant that looks like this, or a matrix that looks like this. I'm just throwing in any numbers. It really doesn't matter. And calculate the determinant, and you will get a 0. Third property, if any two rows or any two columns of a determinant have corresponding entries that are equal, the value of the determinant is also 0. So that I would maybe take the same determinant that I showed you before, but instead of having zeros, I'd put in a column equal to another column. And when you go through the calculation, you will also get 0. Test it. Fourth one, if any row or column of a determinant is multiplied by a non-zero number k, the value of the determinant is also changed by a factor of 0. So let's say we have a determinant. I'm going to change this one again. So now I can't have them be the same. So this new column will be 2, -4, 7. And I would find what it is. It's going to be some number. We'll call it D for determinant. And then I would take this matrix that you have here and just go and take, we can do a row or a column. So maybe the first row, I'm going to multiply it by 3. So we'll have 6, 9, 3 for the first row now. The rest stays the same. And when you find the determinant of this new matrix, it will be whatever you had before, but times 3. Because you essentially applied a scalar with a k of 3 to one of the rows or columns, and that factor is now a result of your determinant. All right, last property. If the entries of any row or column of a determinant are multiplied by some value k, and the result is added to the corresponding entries of another row of column, the volume of the determinant remains unchanged. So if you do this where we take that first row and we multiplied it by k, but then we added that to another row, then we would find the determinant does not get multiplied by the 3. And that is another good one to test. You can also look at your book to see how that works. Another neat thing that can be done with the determinant is to quickly find the area of a triangle. So we're going to be using determinants to solve systems of equations, which we'll learn in our next lesson. But take a look at this example. If you're given a triangle in the coordinate plane and it has vertices at these 3 ordered pairs, we can quickly set up a determinant with each ordered pair listed, going across in a row, fill in ones, so we end up with a 3 by 3 square determinant, and then multiply it by positive or negative 1/2. So I essentially multiply it by half, and then I just make my result positive. Remember, we're looking for the area of a triangle, so area is a positive concept, so you're just going to make whatever value you get, multiply by half, and then take the absolute value of it. So go ahead and try that with these 3 vertices here, and then I will show you the answer. Pause your video now. All right, so the area of this triangle is 7, and I use the diagonal method. You can see my work here. One thing that's kind of neat, well, we don't have units on this because it's just in the coordinate plane, but if you plot it, you can kind of see that it should make sense. 2, 3, 4, 1, 2, there we go. And then we have 3, -4. So this is our triangle. It's not very big. And with those units, the area is exactly 7. Pretty neat extra little use of a determinant. Go ahead and try your homework on determinants.